How would you read this decimal number, Irving?
How about 0.25463?
Not quite. How about you, Bruno? How would you properly read this decimal number?
I have no idea, Mr. Cox.
Okay. The first step in understanding decimal arithmetic is to be able to understand decimal numbers. Let me list the things we'll be covering in this video.
First, we will learn how to properly read a decimal number, and we'll learn how to tell the decimal place value from the numerical part. Next, we will learn how to change decimal numbers into fraction numbers, and then learn how to change fraction numbers back into decimal numbers. Then we will learn how to compare decimal numbers to each other. And finally, we will learn how to handle word problems with decimals and fractions in them.
Now let's get started. Reading a decimal number is not that much different than reading a whole number. There are a few minor differences which I'll explain. Let's take this number again. Let me remove the decimal point for a moment and turn it into a whole number. Then ask you to read it, Irving.
Well, that's easy. It's 25,463.
That's correct. Whether you realize it or not, when you read that number, you also read each of the numerals' place values. Just by reading the number, you had to know the place value of each digit. Let me show you each numeral's place value. The 3 is occupying the 1's place. The 6 is occupying the 10's place. The 4 is occupying the 100's place. And the 5 is occupying the 1000's place. And the 2 is occupying the 10,000's place. Now, reading a decimal number is not that much different than reading a whole number. There is a few differences, and if you can read a whole number, you should be able to read a decimal number if you just remember those minor differences. When you read the place values in a regular whole number, you start from the right-hand side, and the place values start with the 1's place. When you read the place values in a decimal number, you start reading them from the left to the right with the first number after the decimal point, and there are 2 differences from whole numbers. The first place value has no 1's place. A decimal number starts at the 10's place with a th on the end to identify it from a 10's place in a whole number. All decimal place values have a th on the end to identify them as decimal place values, whereas without the th, that would mean whole number place values. Now let's read off all place values in this number starting with the 10's place. The second place value in a decimal number is the 100's place. The third place value in a decimal number is a 1000's place. The fourth place value in a decimal number is a 10,000's place. The fifth place value in a decimal number is a 100,000's place. As you can see, the place values increase like whole number place values except for 3 differences. 1. You start reading them from the left to the right instead of the right to the left. 2. They do not have a 1's place value. They start with the 10's place value, and they are the same as whole number place values except they have a th on the end of them to show that they are decimal place values and not whole number place values. So in this decimal number, what's the last place value, Bruno?
100,000s.
Yes. Now let me show you how to properly read a decimal number. Unlike a regular number, with a decimal number you have to do 2 things. First, you have to determine the last place value of the number because you're going to have to know that after you read the number part. In this decimal number, the last place value is 100,000ths. Now how would you read the number itself, Irving?
You mean the 25463?
Yes, read it just as you would a regular number, ignoring the decimal point for a moment.
Okay, 25,463.
Now you speak the place value to identify it as a decimal number. If you were to stop there, everyone would think you're talking about a whole number.
100,000s. Let me try this from the beginning. 25,463 100,000s. Is that right?
Yes, it is. Now let me change the number slightly to see if we can properly read it. I want you to read this number properly. The first thing you should do is to determine the place value here. What is the last place value here, Bruno?
The first place is a 10's place. The second one is a 100's place. The third one is a 1000's place. And the last one is a 10,000's place.
Correct. So our number is in the 10,000's place. Now read the number part and attach the place value onto it when you finish reading it.
Okay, 2,546 10,000ths.
Excellent. Again, let me change the number slightly. Irving, what's the last decimal place value in this number?
The first place value is tenths. Second place value is hundreds. The third and last place value is thousands. So the number's in thousands.
Yes, now read the number part, then attach the place value onto that when you're finished reading it.
So you read it as 254 thousandths.
That's right. Now let me change it again. Bruno, tell me what the last place value is in this decimal number, then read the number properly.
The first place value is tenths, and the next and last one is hundredths. In order to properly read this number, I have to read the numerals first, then read the last place value to it. It's 25 hundredths.
Correct. One more. Irving, tell me the place value in this number, then read it.
The only place value here is tenths. And to read that number properly is 2 tenths.
Very good. Now here are several more decimal numbers I'd like you to read. Remember to first figure out the decimal place value before you read the numerical part.
Okay, the first one is in the thousands place value, and the number part is 206, so it's 206 thousandths.
The next one's place value is 10 thousandths, and it's read as 105 10,000ths.
The third one is also 10 thousandths place, and you read it as 7 10,000ths.
The fourth one is in the thousands place, and it's 625 thousandths.
The next one is in the hundreds place, and it's read as 78 hundredths.
The last one is in the tens place, and it's read as 6 tenths.
That was very good. Now here's a list of decimal place values up to 6 places. In order to know how to read decimal numbers properly, you must be able to remember these place values. 1 decimal place is tenths. 2 decimal places is hundredths. 3 decimal places is thousandths. 4 decimal places is 10,000ths. 5 decimal places is 100,000ths. 6 decimal places is millions. You will have to know this information when you're changing decimal numbers into fractions, so it's a good idea to memorize these place values. Now what about a number like this? It's not much different than reading a decimal number. First you read the whole number part, then you read the decimal point as the word and, then read the decimal number. Here the whole number is 3 and 15 hundredths. Irving, how would you read this number?
Well, the whole number part is 18. You read the decimal point as and the decimal place value there is thousandths. So I read it as 18 and 205 thousandths.
Good. How about this number, Bruno?
It's read as 8 and 200 thousandths.
Yes, one more number, Irving.
You read this number as 106 and 5 tenths.
Okay, now let's see if we can take a decimal number and write out its value in words.
What do you mean, Mr. C?
Let's take an example. Let me write this number in word form. First, I must write the numerical portion, which is 206. Then write the place value next, which is thousands. Now let me write this number in word form. The numerical part is 78. The place value is hundreds. Bruno, can you write this number in word form?
I think I can. The numerical part is 625, and the place value part is thousandths. 625 thousandths.
That's correct. Irving, can you do this number?
I sure can. The numerical part is 105, and the place value is 10 thousandths. So it's 105 10 thousandths.
Excellent. What about this number, Bruno?
That's written as 53, which is the whole number part, and 25 hundredths, which is the decimal part. 53 and 25 hundredths.
In this section, we will study how to change fraction numbers into decimal numbers, then change decimal numbers back into fraction numbers. I'm going to assume that the viewer has learned fraction arithmetic because there are certain things you must know about fractions to be able to do some of the problems that we will introduce in this section. First, let's change some simple fraction numbers into decimal numbers. Let's take the first number on this chart. I want to ask you just what that object is.
Well, that's easy. It's a fraction.
How about you, Bruno? What would you say this is?
I have to agree with Irving. It's a fraction.
Okay, now let me ask you another question. What is this word?
Well, that's easy too. It's record.
Wait a minute. Isn't that record? Now I'm confused.
That's because the word has more than one meaning. It could be the noun, record, or the verb, record. Now, the next time someone asks you what this word means, you should answer that you don't know because it has more than one meaning. Now let's go back to this number again. It actually has several meanings. We'll focus on two of them here. This could be the fraction 1/4, or it could also be read as a division problem, 1 divided by 4. If you read it as a fraction, here's how it's interpreted. If you've had fraction arithmetic, you should know that the bottom of the fraction always tells you how many equal pieces an object was cut into, and the top tells you how many of those pieces you're talking about. Here we're talking about one part out of a total of 4 parts. But if we want to change this number into another form, we have to do some work, and in math that usually means some arithmetic operation. And as long as this can also be read as a division problem, 1 divided by 4, we have our arithmetic operation. You write the division house alongside the bottom number, and picture tilting the fraction so that the top number slides off into the division house. So we're dividing 4 into 1. It's important to remember here that the top number of the fraction always goes into the division house, and the bottom number always goes on the outside. It will never be the other way around. Let me ask you another question before we go any further. How many ways can you write the number 3?
Is this a trick question, Mr. C?
No, not really. This is something all students should know. Any whole number can be written as a fraction simply by writing the number over 1, and any whole number can also be written as a decimal number simply by writing a decimal point behind the number and placing a 0 or zeros behind the decimal point. Now back to our division problem. When you're dividing a larger number into a smaller number, you'll have to write the number inside the division house as a decimal number and carry it out to several place values. We'll use 2 place values here. Once you've placed your decimal point in your problem, the next step is to place the decimal point in your answer directly above the decimal point in your problem and start doing regular division. 4 divides into 10 at most 2 times. Perform subtraction and bring down the 0 and divide again. 4 divides into 20 evenly 5 times with no remainder. So as you can see, we've just changed a fraction 1/4 into the decimal number 25 hundredths. Now how about the next fraction? Could you change 1/2 into a decimal number, Bruno?
I can try. I have to read this as a division problem, and here's how I do it. Write the division house alongside the bottom number and picture tilting the fraction so the top number slides off into the division house. So we're dividing 2 into 1. In order to divide a larger number into a smaller number, we have to write the smaller number as a decimal and place some zeros behind the decimal point. Next, we place the decimal point in our answer directly above the decimal point in our problem and perform regular division. 2 divides into 10 evenly 5 times with no remainder, so we don't have to go any further.
Correct. You've just written the fraction 1/2 as a decimal number 5/10. Now how would you write the next one, 3/4, as a decimal number, Irving?
You write the division house alongside the bottom number and let the top number fall inside. Next, you write the 3 as a decimal number and place 2 zeros behind the decimal point. Place the decimal point in the answer directly above the decimal point in the problem and start dividing. 4 divides into 37 times with a remainder of 2. Bring down the 0, and 4 fits into 20 evenly 5 times. So the fraction 3/4 can be rewritten as the decimal number 75 hundredths.
Now let's see if we can change those decimal numbers back into fraction numbers. Let me do the first one. How would you read this number properly, Bruno?
It's read as 25 hundredths.
Yes. Now let me show you how to change it back into fraction form. The numerical part always goes on top of the fraction, and the place value always goes in the bottom of the fraction like this. How would you write hundredths as a number, Irving?
I guess it's 100.
That's right. Since our decimal is in the hundredths place, we place a 100 in the denominator. Another way you could remember this is to write the number in the top of the fraction, then place a 1 in the bottom, and count your place values in your decimal number. Here we have 2 places, so we place 2 zeros in our denominator. One more step is that this fraction can be reduced top and bottom by the common number 25 to get 1/4. Irving, can you change a decimal number 5/10 into a fraction?
You write the number part in the top of the fraction, which is 5. The place value is in tenths, so 10 goes in the bottom of the fraction. If you ever forget decimal place values, you could also write a 1 in the bottom, and because tenths is one place value, you put 1 0 in the denominator of the fraction. One more step is that this fraction can be reduced by the common divisor 5, which reduces to 1/2.
Correct. 5/10 can be rewritten as a fraction 1/2. Bruno, can you change the last decimal number into a fraction? And make sure you reduce it to its lowest terms if it can be reduced.
Yes, you write the numerical part on top of the fraction, and since the place value is in hundredths, we write 100 in the denominator. In case we forget decimal place values, we can always write the numerical part in the numerator, then write a 1 in the denominator, and since the decimal has 2 places in it, we put 2 zeros behind the 1 and we still get 100. Next, since 75 and 100 have a common divisor 25, the fraction can be reduced to 3/4.
That's correct. 75 hundredths can be rewritten as a fraction 3/4. Now I should tell you that not all fraction numbers divide evenly with no remainders. Some fractions will divide endlessly without ever stopping. There are 2 ways you can handle this, and let me show you both ways. Each one has its advantages and disadvantages, so you'll have to decide on which one you're going to use depending on your problem. When you change 1/3 into a decimal, you know you have to write the numerator inside the division house and the denominator outside. Then you place your decimal points, write some zeros, and start dividing. 3 divides into 10 3 times with a remainder of 1. Bring down your next 0, and 3 divides into 10 again 3 times with a remainder of 1. If we keep dividing, we're going to keep getting a remainder of 1, so we'll stop after 2 places, and here's how we write the remainder. We take it and write it as a fraction 1 over the divisor 3, or 1/3. This number may look a little strange, and you may not be sure how to read it. It's read as 33 and 1/3 hundredths. It's a little bit larger than 33 hundredths, but not as large as 34 hundredths. You don't normally use this form of a decimal number. Instead, you would round it off, as in this example. Here you'd first determine at what place value you're going to round off your answer, and you carry out your division one more place than where you want to round off your number. Let's take a moment and look at the concept of rounding off decimal numbers before we continue with this problem. Let's say I want to round off 3,546 10,000ths to the thousands place. Here's how we do that. We have to locate the thousands place value, since that is the last digit we're going to keep, and we're going to get rid of all the place values past that number. The rule is that we have to look at the number to the right